All right. So the following questions are questions 7 through 12. And we're going to do some composition of functions right here. It's going to be very fun. It's going to be very easy. Now, the fun part, well, in order to get the fun part, you have to make sure that you can see the inside and outside. All right. So you don't freak out. So F for the question number 7 here. For question number 7 here, F it's on the outside. So we are going to load up the F function first. Okay, x squared plus 12. And what is inside the x right here? Well, that is going to be our g, function g, which is x minus 1. Okay. This question, it is one of those easily missed questions from last year. I guess the reason why many students they tend to miss this question was because they were not very familiar with the reading of notation. So if you can practice reading the notations, you should be good. And you will go ahead and simplify, okay? It's yeah, there's some points sticking off if you don't simplify, but it's not just about the points. It's really about a habit that if you can see something that could be simplified, reduced, you go ahead and do that. So we'll say x minus 1 plus 12. So that gives you x plus 11. Okay, so that's x plus 11. That's f of g of x. And then you have g of f of x. So I'm going to load up my function g first. And then it's going to be x minus 1. And the x will be replaced by now f of x. Okay, f of x would be x squared plus 12. And of course, you've got to simplify this. So you have x squared plus 11 underneath the square root, and that will be your g of f of x. Very simple, all right, nothing really challenging in this case. So you would go ahead and just go do the simple substitution. And I just realized I forgot to type in closing parentheses over here. So, all right. So nothing really challenging at this point, okay, for number 7 and 8. What is going to be challenging? It's going to be 9, 10, 11, and 12. These 4 questions could be a little bit challenging, okay? Domain of f of x. Okay, domain of f of x. Well, if you look at f of x, what could x be? And I could also ask the question, what couldn't x be? Well, it's a quadratic, and x could be literally anything, all right? Anything it's okay with a quadratic. There's no restriction. It's not like square root that we say, we don't want something for the number underneath the square root, right? But for quadratic, it's okay. So now, if you look at the top of the page, it says all intervals must be expressed in interval notation. So if you place this as the answer, I'm sorry. I have no choice but to take off a few points. Okay, so make sure you know how to say all real numbers in interval notation. That would be like this. Okay, that will be like this. And for g of x, okay, for g of x, what's going to happen? It's you want to make sure that everything underneath the square root, it's going to be, okay, I hope there's a voice in your head. It's going to be at least 0 or greater than 0. So you can think about, x minus 1 must be greater than or equal to 0. So that means x must be greater than or equal to 1. Okay. Yeah. And now sometimes we do make careless mistakes. And if you happen, well, you never know if you make a careless mistake. If you do, we never lose so many points, right? So how can we catch our own careless mistakes? Okay. Now, for example, somebody, okay, because it's a test, they put this instead, okay? X is greater than -1. So what you can do, it's just to be curious. You think about, okay, if x is bigger than -1. So you look at this part right here. Can x be 0? And you're like, no, x cannot be 0. So therefore we know something is wrong. It's x equals to 1, okay? So that's one way you can catch yourself, okay, if you happen to make a careless mistake. Now, the other way to catch your own careless mistake or to prevent yourself making careless mistake is to use the graph. Now, square root of x minus 1 is a simple function, simple square root function. It's easy to graph. However, to know how to graph it, you may need to know a little bit on transformation from last year. So this is a square root graph that's being moved to the right for 1 unit. Okay, so if you know the graph, then you would also know that x value can only start from 1 and it goes all the way to infinity. Okay, so there are multiple ways you can protect yourself, and knowing how to graph would definitely be a good way to protect yourself. All right, and then for number 11, things are going to be a little bit bumpy now. Okay, we have f of g of x. Okay, we have f of g of x. Now we have two competing answers. If you have done it, see which answer you have. One answer could be negative infinity to infinity. Okay. The other competing answer would be from 1 to infinity. Now, there are good solid arguments for both, but only one of them is correct. Okay. For those who argue that it's negative infinity to infinity, they would say, wait, go ahead, take a look at the end. The end for number 7, which is f of g of x, it is just x plus 11. It's a linear function. It could be anything. And we're like, oh, that sounds reasonable, all right? But on the other hand, there are people who would say, wait. Don't look at the very end. You look at the beginning. Look at this. You have to do a square root first, right? PEMDAS, square root first, inside of parentheses. So you can't really have a number for x less than 1. If you have any number less than 1, you don't really have a number. So now, which one is correct? Okay. I give you 3 seconds to think about it. All right. The correct answer is 1 to infinity. Okay. So we will never, ever use the simplified finalized expression to find our domain. Never. Instead, we will always use whatever that's written at the beginning to express our domain. Okay? I repeat, we will always use whatever that's written at the beginning without any kind of simplification to be our domain. Okay? Now, just to illustrate how that works on a calculator, I'm gonna show you a picture here. Just give me 1 second. So here we have a little graph on Desmos, and so I'm going to put down the square plus, is it plus 12? It is plus 12, right? And then inside the parentheses, I'm going to write down square root of x minus 1. So what you can see here is that you can see the graph, it stops at, well, where does it stop? 0, comma, that would be 12. No, sorry, not 0. 1 comma 12. 1 comma 12 right here. It stops right there. Nothing to the left of x equals to 1 for that precise reason. Okay. That's just no way that you can have anything that's less than 1, because that would make the square root become imaginary, and well, we don't have a graph to show for it. So again, we always use the original to determine our domain. So when we look at g of f of x, okay, g of f of x, we look at this particular one and we say, well, seems like everything is good because it's being squared. And inside the parentheses, it's always going to be at least 0. And we don't think there's any concern of, we don't think we have any concern of this graph being imaginary or yeah, whatsoever. So we will say from negative infinity to infinity because x could be, well, not here. I mean, x could be anything, and this square root function would still perform just fine, okay? Not anticipating any negative value underneath the square root. So everything is really good to go. So again, just make sure that you know. I think question 11 is one of the more challenging ones um, uh, throughout the whole chapter. It's just that, do you know what to read, and do you have a solid reason to support your action? That's really it. Okay.